Hello everyone, welcome to Sucrose classes. This is Tushar Shaw, and in this video we'll be learning about basically we'll be continuing to solve the BHU PET 2020 questions that we were solving since the 11 videos. Okay, so we did up till question number 11 in the last video, so we'll be starting from question number 12 in this video. But let us firstly discuss a bit about the structure of the examination paper, that is what is BHU PET, and like a small brief introduction about the paper, and then we'll be moving on to the questions so that you may follow up with the exam as well. Okay, so basically BHU PET is an exam arranged for MSc in basically an MSc in chemistry. Basically, we are solving the papers of chemistry for admission in MSc in chemistry at the Banaras Hindu University. So BHU Banaras Hindu University basically conducts this exam PET every year, and the paper that we are solving is 2020 CY, that is chemistry paper. This paper basically are also available for physics, maths, zoology, botany, all the kinds of subjects. And the main thing about the paper is that it has basically 120 questions that needs to be solved in 2 hours at the day of the examination. So basically it is a very like a hectic job to solve also all sorts of questions that are given, be it difficult or easy. We have to solve all these questions in this such low amount of time, but things are like that only. We can't do much, so we have to just understand the concept properly that I am explaining in these videos, via solving the questions. And from that we'll be moving on to after the questions are solved, it will be like easy for you to solve the questions quickly, because then you might have understood the concepts, and it will be very easy. It will be like very let us say very predictable for you to solve. Okay, so the marks distribution is for 2 marks will be awarded for each and every right question, and half marks will be deducted for each and every wrong answer that you attempt. Okay, so basically this was all about the concept. So let us look at question number 11 and let us see whether we can solve it or not, and what are the concepts related to that. Okay, so sucrose is made up of units each of. Okay, so basically sucrose is a disaccharide, we all know. Let me just change the ink. um, so sucrose is a disaccharide, as we all know. Okay, what does a disaccharide mean? A disaccharide is combination two of two monosaccharides. Okay, basically what are the two monosaccharides over here? The subsequent units of sucrose is sucrose can be like hydrolyzed into some form of glucose plus some form of fructose. Okay, so this is basically, as you like in the options only, you can predict that some form of glucose and some form of fructose is also already formed, obviously. Okay, if we hydrolyze this, so basically what is the form of glucose which is formed, and what will be the mm, yeah, so what will be the configuration of those glucose and sucrose? So let us firstly draw these alpha D and beta D glucose from their initial structure, so that you can like easily figure out what will be the exact structure. Okay, so let us take glucose for example. First of all, we'll be taking glucose and we'll be converting it into the glucosides, and then we'll be doing with same with the fructoses. Okay, so I am just drawing the conversion. In the last video I have just explained how this conversion works. So if you are not seeing, you may just see the question number 11 video already uploaded on Sort of the Classes channel. Okay, in that I have explained it properly. So in this video I won't be going quite with quite explanation. I'll be just drawing and then I'll be explaining. Okay, so what would happen is, say double bond O H, this would be attacking over here, this bond will be opening up, we will be getting two structures basically, CH2OH, 1 2 3 4 5, we have O H H OH H H, we have OH OH H OH, This is one structure plus CH2OH 2, 3, 4, 5. We have over here OH, H, OH, H. We have OH, H, OH, H, H. Okay. Converting these into the respective, like just rotating the carbon so that we can get a clear view of how to convert it into the hemiacetal form. Okay. So we'll be getting, I mean, draw it properly. So 1, 1, 2, 3, 4, 5. Okay. So we have CH2OH over here. Yeah, CH2OH. I'm sorry, just a second. 1, 2, 3, 4, 5. Okay. CH2OH, H, H, OH, OH, H, H, OH, H, OH. Okay, this would be one of the structures, plus, and the other product would be um, CH2OH, H, OH, H, OH, H, and here we'll be having OH, H, OH, H, and these are the like two cyclic products. Now let us draw it in the whole cyclohexane type of form, and then like we'll be finishing the work. Okay. So as I've already told you, this the groups on the left hand side of the plane structure of the line structure, we will be using you will be using the left hand side groups in the above, you will be keeping it above the plane, and the groups on the right hand side will be kept below the plane. Okay. So H, I'm sorry, yeah. So H, OH, H, OH, OH, H, uh, H, OH, and we have CH2OH and H. This is basically alpha D glucopyranose. Okay. Then again we just will just draw the other structure for the beta D. We will be having the other structures same, only the anomeric carbon would be changed. I have already explained it in the last video. Okay. So H, OH, OH, and H. Okay. So basically this is beta D glucopyranose. Now in a similar way, as we have drawn the glucopyranose structure, we will be drawing the fructofuranose structures also. Okay. So I'll be using green pen for that. So let me just draw the structure of fructose for you firstly. CH2OH, CH2OH. We have double bond O. We have H, H, OH, and we have H, OH, OH. Okay. So here this would be attacking over here. Okay, and then we'll be having two structures. Again we have CH2OH, CH2OH. We have um, so H would be over here. I'm sorry. Yeah. So OH would be either over here. Yeah. So H, OH. I'm sorry, not OH. Here the OHs are attached, obviously. So H, OH, OH, H, and here the bonding would be there. Okay. Another structure would be formed. I'm not like I won't be able to draw the structure in this way because it is not possible to draw it in this way. So I'll just explain it to you. So here H is there, O. Here we have H, OH. We have OH, H, and this oxygen will be bonded from this side of the part. This side will be bonded to the, like this is bonded to the oxygen part. They are here attached, and on the right hand side there will be OH. Okay, so the attachment is like kind of this one. Okay, so from this let us draw the structure over here. Let us again convert it. So CH2OH will be there. We'll be writing it O. This will be moving around. So we have OH. We have this bonding. We have H over here. CH2OH over there, and H OH OH H. In a similar way, we have CH2OH O. OH will be over here in this way. Okay, so basically so we are rotating it this way. So CH2OH H H OH OH H. Okay, now we just convert this one to the fructofuranous form, which is basically this structure. Okay, 1 2 3 4 5 membered ring. This will be the part. Again we have OH, sorry, CH2OH over here. We have OH down below. Then we have OH over here, H down below. We have H over here, OH down below, and we have CH2OH over here and H down below. Okay. So and then from here we'll be getting just the anomeric carbon will be changing. So this one is the anomeric carbon. So this one will be changing. Just so we'll be having the same structure other than this one. Only here will be the OH and here will be the CH2OH. Here we have this CH2OH and here we have H, and then we have H, OH, we have OH, H. Okay, so this is basically the beta D glucopyranose, beta D fructofuranose, furanose, and this is alpha D fructofuranose. Okay. So this was all about the conversion. Now the answer here will be option C. Okay, option C, that is alpha D glucoside and beta D fructoside. Okay, so alpha of glucose and beta of fructose. So these two structures will be combined so as to give the structure, which is let me just draw it for you. So we will be having this kind of structure. O, we have H, OH, OH, H, OH, H, and CH2OH, and we have H over here. Again, here we have H and here we have O. So this O is bonded directly to here we have CH2OH and we have OH over here. We have OH, H, OH, H over here, and we have CH2OH. Okay, so this is basically the structure of sucrose, and this has bonded alpha D glucopyranose and beta D fructopyranose as the constituents. Okay, so option C here would be the correct option. Okay, so that was all about this video. So I'll be solving question number 13 in the next video. So thank you guys for this video. I'll see you guys in the next one.